Hi, good evening, everyone. Hope you people are doing fine. This is the last and final session of that classes where we are going for the crack hydrology in 15 hours. We have already gone for three sessions. We've already gone for three sessions where generally we have dealt with lot many chapters. Only one chapter is left. The that is nothing but the well hydraulics. So in this chapter, what we will do in this session, first we will uh, go through the first we will go through the well hydraulics in details. Then we'll go for the revision of the whole hydrological segments along with the problem. Okay, so myself Soumyajit Sen, those who know me, done my classes, you people know me very well. First of all, welcome to an academy. Let's crack it. And we are here for Just Get Civil, and we are here for Mission Gate 2021. And we're actually going for a crash course for our Gate 2021. We're going for Engineering Hydrology, Lecture 4 it is. Before going to the subject details, just a reminder that if you want to crack GATE and ESE, it is the India's largest learning platform. Get the subscription. If you don't have the Unacademy learning app in your mobile, then please install it. And myself Soumyajit Sen, I don't have to utter this slides anymore because lot many people know me very well. So if you don't have the Unacademy learning app, please install it. And in this learning app, what you will get daily live classes, structured courses, live test and quizzes, unlimited access. And we are introducing iconic subscription, where you will get a personal coach, where get one-on-one guidance from top exam experts as your personal coach, align your preparation strategy and learning resources, go for the study tracker, mains question answer practice, all benefits of PLUs. There will be plus subscription, daily live classes, and everything will be there. You will get the classes from India's topmost educators, and also you can get classes. I have taken a lot many crash courses on environmental engineering. There in the app itself, you can find it there. A comprehensive courses, brush of courses already I have done with this in this Just Get Civil for environmental engineering. And don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10. Don't forget to apply the code SEN10 ACN10 for any kind of subscription process.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other, where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for date till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
So Unacademy Combat is the India's largest fortnightly competition for GATE. Uh, so it is the challenging and original questions curated by best Unacademy educators. Super fast and fun live fun with all India live leaderboard. Take it live to compete with the best. Identify and improve your weak areas with detailed video solution by top educators. Compete, crack and conquer. So let's go for. तो जैसे मैं आपको पहले ही बोल चुका हूं कि व्हाट विल बी आवर प्रोसेस. वी विल डील विथ लाइक पहले हम लोग क्या करेंगे. We will go for the well hydraulic segment, and then we will quickly quickly go for this. The revision of the whole revision means through problems. We will go for the revisions through problems itself. Okay. So well hydraulics. So water present in soil mantle is called as subsurface water. We want to quickly finish this. That's why I've written all those things. So hope it is visible to you. So water present in soil mantle is called as subsurface water. So based on availability of water, groundwater is classified into two zones. One is zone of saturation, another one is zone of aeration. So due to based on availability of water, groundwater is classified into zone of aeration and zone of saturation. What is zone of saturation? This zone, also known as groundwater zone, in this space in which all the pores of soil are filled with water and the water table forms its upper limit and marks a free surface, i.e., surface having atmospheric pressure. Now, what is zone of aeration? In this zone, the soil pores are partially filled with water. The space between the land surface and the water table marks the extent of this zone. The zone of aeration is having three subzones. What are the three subzones? One is soil water zone, second one is capillary zone, and third one is intermediate zone. So, once again, based on the availability of water, groundwater is classified into zone of saturation and zone of aeration. Now, the zone of aeration is what? And zone of saturation is what? Zone of saturation is the zone which also known as groundwater zone in this space in which all the pores of soil are filled with water and the water table forms its upper limit and marks a free surface having atmospheric pressure. Now, what is zone of aeration? In this zone, the soil pores are partially filled with water. The space between the land surface and the water table marks the extent of this zone. The zone of aeration is having three subzones: soil water zone, capillary zone, and the intermediate zone. Now, the definition of these subzones are given here. What are the subzones? First of all, soil water zone. This lies close to the ground surface in the major this lies close to the ground surface is the major root band of the vegetation from which water is transported to atmosphere by evapotranspiration. जो पानी एक्चुअली रूट के जरिए से transported हो सकते हैं and those पानी the water which can be evaporated to the atmosphere itself. Now capillary zone. What is capillary zone? In this subzone, the water is held by capillary action. In this subzone, the water is held by the capillary action. What is intermediate zone? This subzone lies between soil water zone and capillary zone. Intermediate zone is the subzone lies between soil water zone and capillary zone. This is the schematic which is actually showing. This is the whole thing is called as the zone of aeration. So from the top part, this is bedrock. This is zone of saturation. So groundwater table to the bedrock is called as zone of saturation. From the soil surface to the groundwater table is called as zone of aeration. Now, this segment, the first segment is soil water zone, which is actually attached with the soil surface. The zone which is attached with the groundwater table is called as the capillary zone, and in between them is called as the intermediate zone. In between them, it is called as the intermediate zone. Now, zone of saturation is further classified into four categories depending on the storage and drainage property. The zone of saturation is further classified into 4 categories, depends on the storage and drainage property. They are aquifer, aquitard, aquiclude, and aquifuse. Aquifer, aquitard, aquiclude, and aquifuse. What is aquifer? An aquifer is a saturated formation of earth material which not only stores water but yields it in sufficient quantity. मतलब सिर्फ स्टोर नहीं, ये पानी दे भी सकता है sufficient quantity में. Thus an aquifer transmits water relatively easily due to its high permeability. As example, sandy soil. मतलब ये सिर्फ पकड़ता नहीं है, छोड़ता भी है easily. Now coming to aquitard, it is a formation through which only seepage is possible and thus the yield is insignificant compared to an aquifer. मतलब ये लेता है लेकिन छोड़ता उतना अच्छा नहीं. Formation are porous but are semi permeable. As example, sandy clay soil. What is aquiclude? It is a geological formation which is essentially impermeable to the flow of water. It may be considered as close to water movement even though it may contain large amount of water due to its high porosity. And example is clay. And aquifuse is neither porous nor permeable, compact rock. Clear? Now, quickly we will go through this. Properties of aquifer. Properties of aquifer, here it is mentioned. 3 properties are there. One is porosity, specific yield, and specific retention. What is porosity? We know very well. N is defined as the amount of pore space per unit volume of aquifer is called as porosity. And N is VV, volume of voids by actual volume of soils. It is the measure of storage property of an aquifer. So where N is greater than 20%, sufficient water is stored. 5 to 20% moderate, less than 5%, low amount of water is stored. Specific yield. It is defined as the amount of water that can be extracted from the ground by force of gravity from unit volume of aquifer. It is defined as the amount of water that can be extracted from the ground by force of gravity from unit volume of aquifer. So specific yield is equals to nothing but volume of water extracted by volume of aquifer. So suppose this is your groundwater table 1. After extraction, delta GWT, the groundwater table defines to 2. So this is the groundwater table 1 is the position before extraction and groundwater table 2 is the position after extraction. So eventually delta groundwater table, the change in position of groundwater table is nothing but the thickness of aquifer from which water is extracted. It is nothing but the thickness of aquifer from which water is extracted. Where volume of aquifer from which water is extracted will be area into the thickness, that is volume. So change in groundwater storage will be equals to volume of water extracted. So delta GS is SY, specific yield, into area into change in the thickness of aquifer from which water is extracted. And specific retention is nothing but action of water retained by the soil against the force of gravity. And porosity will be specific yield plus specific retention. Porosity will be specific yield plus specific retention. Then Darcy's equation. What is Darcy's equation? Groundwater movement, yield, anything related to groundwater is governed by Darcy's equation, where it is V equals to K into I. V equals to K into I, where V is the apparent velocity of seepage, which is Q by A, where Q is the discharge and A is the cross-sectional area of porous medium. A is the cross-sectional area of porous medium, and K, coefficient of permeability, is having velocity unit. I is the hydraulic gradient minus dH ds. H is piezometric head. S is the distance measured in the general flow direction. Q equals to K into A into I, or K into A into minus dH ds, where actual velocity VA is equals to the apparent velocity by porosity. Quickly have a look. These are the very important formulas for your problem solving approach. These are the very important formulas for your problem solving approach. Now, based on the positioning of aquifer, they are classified into two types. One is unconfined aquifer, another one is confined aquifer. Unconfined aquifer is also called as water table aquifer, and confined aquifer is called as artesian aquifer. So what is unconfined aquifer? Having one boundary. Confined aquifer is sandwiched between two impervious layers. Sandwiched between two impervious layers. In the unconfined aquifer, the free water surface is present, and in confined aquifer, yield constant rate of flow. Water flow due to gravity in unconfined aquifer, but in confined aquifer, flow will be under pressure. Quickly have a look on this process. Now, we are going for wells. Quickly, we are going through wells, the most important segment from where you can expect questions. Wells. It is the most important mode of groundwater extraction from an aquifer. देखिए, गौर तरीके से समझने का कोशिश कीजिए मेरे पॉइंटर को. ये है आपका impervious बाउंड्री नीचे वाला, ठीक है, और ये है आपका वेल. तो जब पानी लेगा ये वेल, क्या होगा? ये है ओरिजिनल वाटर टेबल. तो जहां पे वेल है वहां से पानी लेके निकलने का कोशिश करेगा. जैसे ही वो लेके निकलने का कोशिश करेगा, देयर विल बी कॉनिकल फॉर्मेशन, और अगल बगल से क्या होगा? जैसे यहाँ पे डेफिशिट इन वाटर होगा, टू मेंटेन द इक्वल वाटर फोर्स थ्रू आउट द प्रोसेस, देयर विल बी सम वाटर फोर्स टू दिस कोन ऑफ डिप्रेशन. ये कोनिकल स्ट्रक्चर को कहते हैं कोन ऑफ डिप्रेशन. And these are the two observation wells. This is the pumping well. This is called as the cone of depression, and this is called as radius of influence, and this is the pumping well diameter 2r. Quickly have a look on this diagram, please. It's an example of unconfined aquifer. It's an example of unconfined aquifer. So now we need to go for yield. तो यहाँ पे देखिए ये वाला जो ओरिजिनल वाटर टेबल से ये S2 है तो ये H2 है, टोटल ये हाइट है H, ये S1 है, ये H1 है। सबसे बड़ी बात है कि जो मैंने नहीं बताया कि ये जो वाटर एक्सट्रैक्शन और ये जो बगल से पानी आना, दिस कोन ऑफ डिप्रेशन एट इक्विलिब्रियम रेट, इट विल एट एन इक्विलिब्रियम रेट, जब जितना पानी लिया जा रहा है उतना ही पानी बगल से भी आ रहा है, सो इवेंचुअली दिस कोन ऑफ डिप्रेशन विल बी sustaining for a certain point of time. So DUP assumption is at equilibrium of steady state, flow into the well is flow out from well, Q is pumping rate. What you need to know is the final form of the equation. H is the thickness of aquifer, R is the radius of influence. H is the thickness of aquifer, R is radius of influence, and S is drawdown. So S1 is drawdown at first well, S2 is drawdown at second well. Quite obviously H1 is H minus S1 and H2 is H minus S2. R1 is the radius of first test well, R2 is the radius of second test well. We know that Q equals to K into I into A. K into I is dH dr and area is 2 pi RH, conical substances. So if you integrate from R1 to R2 dr by R, H1 to H2 K by Q 2 pi R H into dH, where final form Q will be equals to pi K into H2 square minus H1 square by ln R2 by R1. Q is equals to pi K H2 square minus H1 square whole by ln R2 by R1. Now a term I am introducing that is called as coefficient of transmissivity. A term I am introducing called as coefficient of transmissivity. So what is that? It is discharge per unit width of an aquifer. Discharge per unit width of an aquifer, and it is used to compare between two wells. For unconfined aquifer, T is equals to K into H. For unconfined aquifer, T is equals to K into H. Now yield from a well laid in confined aquifer. Yield from a well laid in confined aquifer. So confined aquifer sandwiched between two impervious layer. Once again, the final form of equation will be Q equals to 2 pi K into B H2 minus H1 by ln R2 by R1, where 2 pi K into B S1 minus S2, from where I am getting this here H2 minus S1 is already defined as H minus S2 minus H minus S1 is S1 minus S2. From there only I am writing this ln R2 by R1, and T coefficient of transmissivity is K into B. So from there this 2 pi KB we can write 2 pi into T. So Q equals to pi into T S1 minus S2 whole by ln R2 by R1. Have a look. First from this, that is from confined aquifer. Now we are going for the test on wells. The test on wells is defined by two tests. One is pumping test to find out the K values of soil. Another one is recuperation test to find the specific capacity. What is recuperation test? Suppose this is a well. One is the initial stage. After pumping some water, the 2 is the second stage. Then what you are doing? You are allowed the well to recuperate. Recuperate means recharge. After getting recharged, it is actually in the third position. Understood? So first one is the position of initial position. Then you are taking out some water. That is the position 2. And then after the recuperation, the position is 3. Let the well be pumped at a constant rate Q till a drawdown H1 is obtained. The pumps is now stopped and the well is allowed to recuperate. The water depth in the well is measured at various time interval starting from the stopping of well. H1 is the drawdown at the start of recuperation at time t equals to 0. H dash is the drawdown at time t. So H2 is equals to H1 minus H dash. Specific capacity C is defined by discharge by unit drawdown, which is 1 by T ln H1 minus H2, where Q is equal to C into A into H, where area A is the area of cross section of well, pi by 4 into D square. Note, if C is more, well is good. If C is less, well is bad. If C is more, well is good. If C is less, well is bad. A term we need to introduce, that is intrinsic permeability. That is intrinsic permeability K, which is equal to CD square into E cube by 1 plus E. E is the void ratio into gamma W by mu. This segment CD squared E cube by 1 plus E is soil property. Gamma W by mu is water property. And this soil property is called as intrinsic permeability K naught. So K is equals to K naught into gamma W by mu, or K naught is equals to K mu by gamma W, where mu is equals to mu by rho W, where mu is nu into rho W and gamma W equals to rho W into G. So from here we can say K naught is equals to K mu by gamma W equals to K nu rho W by rho W into G. Rho W cancels, is equals to K nu by G. Unit will be meter square or Darcy, where 1 Darcy is equals to 9.87 10 to the minus 13 meter square. Nu is coefficient of kinematic viscosity and gamma W is unit weight of water. And coefficient of percolation is K by N. That is the thing we are actually having the discussions. Quickly have a look on this recuperation test, then we will go for the problem solving approach. Quickly we have solved. We'll finish well hydraulics and we will revise then. We will revise the whole hydrological part along with problem. The first question, get 2011. Though I have marked the answer, but please solve it. I'm giving you 2 minutes time. Quickly you can solve. First question, get 2011 question. In an aquifer extending over 150 hectare, the water table was 20 meter below the ground level. Over a period of time, the water table dropped to 23 meter below the ground level. If the porosity of aquifer is 0.4 and the specific retention is 0.15, what is the change in groundwater storage of aquifer? The first question. Giving you 2 minutes time. Your time starts now. Don't go with the answer. I'm marked. I've started solving in the right side. But please try yourself. और कुछ ही और 10-15 मिनट बाद ही हम लोग पूरा हाइड्रोलॉजी का पूरा पहले चैप्टर से प्रेसिपिटेशन, देन इवापोरेशन ट्रांसपिरेशन, इनफिल्ट्रेशन रन ऑफ, हाइड्रोग्राफ, फ्लड एंड फ्लड राउटिंग, हर चैप्टर का प्रॉब्लम सॉल्व करेंगे just after 10 to 15 minutes. Don't go anywhere. That will be your final division of the hydrological process. आपका कोई डाउट हो तो आप कमेंट पे लिख सकते हैं. So area is given as 150 hectare. N is porosity 0.4 told. Specific retention is 0.15, that is also told. So what is specific yield? N minus SR specific retention, that will be 0.4 minus 0.15, it's 0.25. Now, so what is delta GW? Is SY into volume of aquifer. So SY into area into the depth of groundwater decrease. The first formula we have gone for, it is 112.5 hectare meter, because in the options are providing to hectare meter. Clear? Very easy to solve. Okay. Now question number 2, 2008, get 2008 question. Question number 2, get 2008. A volume of 3 into 10 to the power 6 meter cube of groundwater was pumped out from an unconfined aquifer uniformly from an area of 5 kilometers square. The pumping lowered the water table from initial level of 102 meter to 99 meter. The specific yield of the aquifer is. Solve this question. Once again, very easy to solve. Once again, 2 minutes time. 1 minute left. Go for the solution of the question. See. So volume of groundwater extracted is equals to 3 into 10 to the power 6 meter cube, which is stored. Area 5 kilometer square, and drop in water table will be equals to, from 102 to 99 meter, it's 3 meter. Asking SY. What is SY? It's volume of groundwater extracted by volume of aquifer, that is 3 into 10 to the power 6 by 5 into 10 to the power 6, because kilometer square to meter square into 3. So it's 0.2 is your answer. Very easy to solve. Okay. If you know this formula, you can easily solve this question. That is question number 2. Now we are going for question number 3. That is your question number 3. Again, answer is marked, but you need to solve this question. This is also GATE question, GATE 2018. An unconfined aquifer of porosity 30%, permeability 35 meter per day, and specific yield of 0.2 has an area of 100 kilometer square. If the water table falls by 0.25 meter during a drought, the volume of water lost from storage in million cubic meter will be. Please solve this question. Again, I am giving you 2 minutes time to solve this question. One minute more. This is the solution. See, porosity 0.3, specific yield 0.2, area given, delta water table 0.25 meter, volume of groundwater extracted. Volume of aquifer is also there, 100 into 10 to the power 6 into 0.25. Area into depth, this. So volume of groundwater extracted is nothing but SY, specific yield, into volume of aquifer. Directly you can go for 5 million meter cube. That is question number 3. Now we are going for question number 4. Please solve question number 4. Figure is given. A steady groundwater flow is occurring through an unconfined aquifer of coarse sand underlaid by a horizontal impervious formation as shown in figure. Once again, a GATE question. Very easy to solve. The depth of water table below the ground surface in the two observation well fixed at a spacing of 290 meter along the direction of flow are recorded as 5 meter and 5.6 meter. The sand layer is 20 meter thick. Its coefficient of permeability is 4 into 10 to the power minus 3 centimeter per second. Determine the rate of flow in meter cube per diameter width of aquifer. Have a look on the drawing figure, then solve, please. Solution. Darcy equation is Q in equals to K into I into A. V equals to K into I. K is equals to 4 into 10 to the power minus 3 centimeters per second. H1 is H minus S1 is equals to 20 minus 5 is equals to 15. And H2 is 20 minus 5.6 is equals to 14.4. K into I into A. So Q directly it's 0.105 meter cube per diameter. Is it clear? Let's go for the next question. Question number 6. Sorry, 5. I've marked the answer. Drawing is also there, but please don't go for the marked answer. Two observation wells penetrating into a confined aquifer are located 1,500 meter apart in the direction of flow. Heads of 50 meter and 25 meter are indicated at these two observation wells. If the coefficient of permeability for the aquifer is 30 meter per day and its porosity is 0.25, then the time of travel of an inert tracer from the one well to another is 50 meter, 25 meter. Dye is applied with the distance is 1500 meter, right? So H1 is 50 meter, H2 is 25 meter, K is 30 meter per day, N porosity is 0.25, time is equals to distance traveled by tracer by seepage velocity. Actual velocity is the velocity by porosity, V equals to K into I, where I is equals to 50 minus 25 dH ds. So from here we can go for the actual velocity, from apparent velocity to actual velocity. Then time taken is distance by velocity is 750 days, will be your final answer. Hope you understand this. Have a look. That is the problem. Question number 6. For a field pumping test, a well was sunk through a horizontal stratum of sand 14.5 meter thick and underlaid by a clay stratum. Two observation wells were sunk at horizontal distances of 16 meter and 34 meter respectively from the pumping well. The initial position of the water table was 2.2 meter below the ground level. At a steady state pumping rate of 925 liter per minute, the drawdowns in the observation wells were found to be 2.45 meter and 1.20 meter respectively. Calculate the value of K. So H is given as 14.5, R1 is 16 meter, R2 is 34 meter and S is 2.2 meter. Q is 925 liter per minute, 1332 meter cube per day. S1 is given, S2 is given, asking to find out the value of K. So H1 is H minus S1, that is 9.85 meter. H2 is H minus S2. And Both the cases 2.2 meter is getting released. It will be 11.1 meter. Q is equals to pi k into h2 square minus h1 square by ln r2 by r1. From here k value we can get it as 12.2 meters per day. 12.2 meters per day. Now we are going for question number 7. Final question. Get 2010 question. Final question. Get 2010. A well of diameter 20 cm fully penetrates a confined aquifer. After a long period of pumping at a rate of 2720 liters per minute, the observations of drawdown taken at 10 meter and 100 meter distances from the center of the wall are found to be 3 meter and 0.5 meter respectively. The transmissivity of the aquifer is, quickly solve it, get 2010. See the solution. Radius of well is R 20 by 210 centimeter or 0.1 meter. Discharge Q is 2720 liter per minute. R1 drawdown, R2 drawdown S2. From their Q, from their T is 576 meters square per day. Quickly have a look. See, just repeating the segment. Then we will go for the problems. আস্তে আস্তে have a look on this. This is the question. Now we are going for the problems. So on the very first, so before going to the start of the problems, I'm just going to take a 5 minutes break and we'll come back. It's 7:12. I'll start the problems from 7:17. Okay. Video will not be paused. It will be there. This is my profile link. So those who want my profile link, I have texted in the live chat. Well, please let me know whether the link is showing or not. Now अभी दिखा रहा है? Open. Well, just http://soumyajitsen.iitb soumyajitsen.iitb -7305 written in this slide. Now we'll go for the problems. Major type of problems we will solve. So first part, precipitation chapter से Question number 1. In a catchment, hope you remember all those theoretical aspects. In a catchment, there are 6 rain gauging stations. With average depth of rainfall of 92.8 centimeter. Standard deviations of the rainfall values recorded is 30.7. For a 10% error, 10% degree of allowable error, the optimum number of station required is quickly solve this question. Chalo, started with our revision with the problems. First question. Ambi? Babon? Babon? এটা একটু এগিয়ে যান, কি করে খাবো? Please solve this first question. So existing number of rain gauging stations M is equals to 6. Average depth of rainfall P bar 92.8 centimeter. Standard deviation 30.7. Error percentage allowed is 10%. So optimum number is CV by epsilon whole square, where CV is equal to 100 sigma by P bar. You put the values, so N is equals to CV by epsilon whole square 33.08 by 10, 10.94, it's 11. Is that clear? Okay. Hope you remember this formula. Question number 2. GATE 2015 question. Question number 2. GATE 2015 question. In a catchment, there are 4 rain gauging stations. This is GATE 2015 question. Question number 2. In a catchment, there are 4 rain gauging stations PQRS. Normal annual precipitations of these stations are 780 mm, 850 mm, 920 mm, and 980 mm. In the year 2013, station QRS are operative, but P was not. Using the normal ratio method, the precipitation of P was estimated as 860 mm. If the observed value of Q and R for that year is 930 and 1010 mm respectively, what is the observed value of station S for that year? Please solve this question. We have gone for normal ratio method. GATE 2015 question it is. Let's solve this question. So for this question, so actually the precipitation of the station P is estimated by normal ratio method. So it will be PQ by normal plus PR plus PS by NS. So it is estimated as 860, which will be 7680 by 3 into 930 by 850, 1010 by 920 plus PS by 980, right? From here, if you solve for PS, it will be 1093.43 mm. That is question number 2. 1093.43 mm. That is your question number 2. So that is from the adequacy of rain gauging stations, that segment. Now we are going for the segment that is called as mean precipitation calculation. Question number 3. Question number 3. The Thyssen polygonal areas of the 4 rain gauging stations A, B, C, D in a catchment are 75, 125, 150 and 150 kilometers square. Respectively. And the rainfall recorded at A, B, C, and D are 3, 5, 4, and 6 centimeter. Then the average depth of rainfall over the catchment in centimeter is. Let's solve this question. Question number 3. So let's solve for this question. Where P bar is equals to PA AA plus PB AB plus PC AC plus PD AD whole by area enclosed for B, A, B, and C and D. 3 into 75 plus 5 into 125 plus 4 into 150 plus 6 into 150 whole by 75 plus 125 plus 150 plus 150. It will be 4.7 centimeter. It will be 4.7 centimeter. That is question number 3. Now we are going for question number 4. We are going for question number 4. For a drainage basin of drainage basin of 600 kilometer square, isohydral is giving the following data. Other than important notifications, I have just uploaded one video with top 8 questions from environmental engineering. Short video is there. You can go through that video itself. Then the average depth of precipitation from the catchment will be. Please solve this question. Just a minute, I'm coming. Let's solve this question. So P bar will be equals to A1 P1 plus P2 by 2 plus to AN minus 1 Pn minus 1 plus Pn by 2 whole by A. Your final answer will be 7.4 centimeter. Like video. Let's go for question number 5. A rainfall of certain high intensity is expected to occur once in 20 years, what is the probability that it may occur at least once in next 12 years? Question number 5, from the frequency of rainfall data. Please solve this question. So let's solve this question. So waiting for your answers actually. T equals to 20 years. So P equals to 1 by T, that is 1 by 20. It's 0.5. So N equals to 12 years. Q equals to 1 minus P, 0.95. Probability of occurring at least once. So 1 minus Q to the power N, 1 minus 0.95 to the power 12. It's 45.96%. The final answer is 46%. We're going for question number 6. A breach has an expected life of 50 years and is designed for a flood magnitude of written period 100 years. What is the risk associated? What is the risk associated with this hydraulic design? Logic design. Please solve question number 6. These are the important, very important type of questions. I've chosen all those types which are already in gate or may come in gate. Let's solve this question. So n is equals to 50 years, t is 100 years, p is equals to 1 by t, 1 by 100, it's 0.01. Q equals to 1 minus p, it's 1 minus 0.01, it's 0.99. Risk, or 39.5%. Okay, next question, question number 7. The return period that a designer must use in the estimation of a flood for a hydraulic structure if he is willing to accept 20% risk that a flood of that or higher magnitude will occur in the next 10 years is. Solve for question number 7. So for this question, risk is given as 20%, which is 0.2, n is 10 years, t asking, so 0.2 is 1 minus q to the power 10, where q is 0.9778. 1 minus q, that is 0.022. It's 45 years. So there are 7 questions from the precipitation chapter. Now we are going for the transpiration, evaporation and transpiration chapter. And a very important type of questions we are going to discuss from this evaporation and transpiration chapter. Please be concentrated here. Always I'm using this pen. Just now I was writing. So question number 8, which is eventually first question from the evaporation transpiration, but as I am doing all those questions at a time, that's why it's question number 8 itself. What is the question number 8, which is eventually first evaporation if 4.2 liters of water is removed from an evaporation pan of diameter 1.22 meter and simultaneous rainfall measurement is 8.75 mm. Solve this question. First question. Second one, third one, and fourth one, all are very important. The chapter questions, very important. So dia is 1.22 meter, volume 4.2 liter, right? So depth of water removed, Z is equals to 4.2 into 10 to the power minus 3 meter cube by pi by 4 d square into 1000 in mm, 3.592 millimeter, right? So pan evaporation, rainfall has occurred, so P plus minus Z, here usually minus Z, it's 8.75, this much rainfall inflow minus 3.592. Hope you understand. 5.157 mm. So 4 point water is removed from pan. So that much what depth of water is removed. So already certain amount of water is in inflow, that is the precipitation. So that much is removed means rest of the part is evaporation, that is there 5.157. Next question, question number 9, another important question. .75 liter of water is added to an evaporation tank sorry, evaporation pan, not tank, mistakenly I have written. Of diameter 1.2 meter to bring the water to a stipulated level. If nearby rain gauge measure a rainfall of 4.2 mm, then what is the pan evaporation? And what is the actual evaporation? If Cp is 0.7, Let's solve this question. Depth of water added pan evaporation. Here it will be P plus Z. Why? Because when it is what plus Z, if water is added, that means more evaporation has occurred, right? Minus Z when water removed. You need to remember this. Less evaporation is occurred. The actual evaporation will be Cp into pan evaporation. Point 0.7 into 11.936 mm, 8.35 mm. That will be the final answer for actual evaporation. Okay. Now question number 10, very very important also. It's GATE 2003 question. This type of question I have already solved on the basis of water budget equation in the first day itself. Hope you remember. The plan area of a reservoir is 1 kilometer square. The water level in the reservoir is observed to decline by 20 centimeter in a certain period. During this period, the reservoir receives an a surface inflow of 10 hectometer and 20 hectometer are abstracted and 20 hectometer are abstracted from the reservoir for irrigation and power. the pan evaporation, and rainfall recorded are 12 centimeter and 3 centimeter respectively. Pan coefficient value is 0.7. What will be the seepage loss during this period in hectare meter? Solve it, please. Let's solve this question. Area given 1 kilometer square, that is 10 to the power 6 meter square. Delta S is minus 20 centimeter, right? So actually minus delta S, whatever it may be, it's inflow minus outflow. So delta S is nothing but outflow minus inflow. Pan evaporation is 12 centimeter. So actual evaporation is 12 into 0.7, 8.4 centimeter. Let seepage loss x hectare meter. So we can say that 20 centimeter by meter into 10 to the power 6 is equals to outflow minus inflow. Outflows, these are all our outflows, plus x into 10 to the power 4 in meter cube, minus inflow is precipitation 10 into 10 to the power 4 plus that is the seepage loss what we have taken, that will be obviously an outflow. So all the cases by 100 is removed. So 20 into 10 to the power 6. I will reduce the calculation step as much as possible. 10 to the power 4, 28.4 into 10 to the power 4 plus x into 10 to the power 4 minus 13 into 10 to the power 4. So 10 to the power 4 removed. So x is equals to 20 minus 15.4. It's 4.6 hectare meter. It's 4.6 hectare meter. Clear? Okay. Hope you understand this process. Now we are going for question number 11. In a particular area, the net radiation is 200 watt per meter square, and Temperature is 25 degrees centigrade. At the above temperature, the latent heat of vaporization is 2441 kilojoule per kg and density is 997 kg per meter cube. The evaporation rate will be. Please solve this question. Question number 11. So R is 200 watt per meter square. L will be 2441 kilojoule per kg. 2441 into 10 to the power 3 joule per kg. R by 7.1 mm per day. Just direct formula use. Let's go for question number 12. At a particular area, pan evaporation for the January month of January is 9.5 centimeter. For a stage growth of 40%, the consumptive use coefficient is 0.52. Then the daily consumptive use for January will be question number 12. So let's solve. So for January, pan evaporation is 9.5 centimeter, K is 0.52, K is Cu by pan evaporation. .94 centimeter, 49.4 mm per month. As this is the month of January, so it's 49.4 by 31. It's 1.6 mm per day. So अभी तक हम लोग जितना सॉल्व किए हैं उनमें से इवापोरेशन ट्रांसपिरेशन तक का प्रॉब्लम सॉल्व हो चुका है. प्रेसिपिटेशन एंड इवापोरेशन ट्रांसपिरेशन प्रॉब्लम्स आर बीइंग सॉल्व्ड ओवर देयर. So now we will go for the infiltration and runoff, and then we'll go for the most important one is the hydrograph. हाइड्रोग्राफ से हम लोग 10-12 डिफरेंट टाइप्स का प्रॉब्लम सॉल्व करेंगे. इनफिल्ट्रेशन से भी हमारे पास 6-7 डिफरेंट टाइप्स का प्रॉब्लम्स हैं. So let's take a break for 5 minutes. It's 9:08. We will be here by 9. Let it be 9:17, 15. Let's take a break for 7 minutes. We'll come back quickly.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for date till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Let's resume the session. So, question number 13, starting with the process of infiltration and runoff. Gate 2000. The question I am writing here is Gate 2000 question. The parameters in Horton's infiltration equation are given as F naught 7.62 centimeter per hour, FC 1.34 centimeter per hour, and K 4.182 per hour. For continuous ponding, the cumulative infiltration at the end of 2 hours will be. Please solve. So we know that Ft is equals to Fc plus F naught minus Fc e to the power minus Kt. So 2 hours F2 is equals to 1.34. So F2 is equals to Fc. So that means it is already reached the equilibrium condition. Total infiltration 4.18 centimeter. Is it clear? Have a look on this process, the solution process. Sorry. Let's go for question number 14, which is eventually get 2006 question. Get 2006 question. During a 3-hour storm event, it was observed that all obstructions other than infiltration are negligible. The rainfall was idealized as three 1-hour storm of intensity 10 mm per hour, 20 mm per hour, and 10 mm per hour, respectively. The curve represents an equation F equals to C 6.8 plus 8.7 exponential minus T, F in mm per hour and T in hour. What is effective rainfall? Please solve this question. Very, very important type of question. Please. Let's solve this question. So FCT is equals to FC plus FC naught minus FC into e to the power minus KT, that we know. So FC naught is equals to FC plus 8.7 is given as per the equation. It's 6.8 plus 8.7, it's 15.5. So try to understand the starting of Horton's infiltration curve is from 15.5, whereas if you plot the rainfall hydrograph, it will start from 10, next one is 20, and third one is 10, right? So here you are starting from 15.5. So it will go like this. So obviously all the rainfalls are not above the Horton's infiltration curve. इसका मतलब है सारे रेनफॉल नहीं होगा, तो effective precipitations क्या होंगे, जो ऊपर है, which is nothing but runoff. Correct. So your runoff will be area of hydrograph above infiltration capacity curve. So area of hydrograph above IC curve will be equals to total area of hydrograph minus area below IC curve. The point is, we won't be able to consider this particular hydrograph, only these two. We have to consider 20 and this is 10. So that is equals to 20 into 1 plus 10 into 1 minus. So this is 0, 1, 2, 3. So 1, 2, 3 FCTDT. Okay. That is 30 minus integration 1, 2, 3. FCT is 6.8 plus 8.7 e to the power minus t dt. 30 minus 6.8 into dt is 6, so it is 6.8 into 3 minus 1 minus 8.7 e to the power minus t to the power minus 1. It will be directly I am putting the limit itself. If you calculate, it will be 13.63 mm. It will be 13.63. mm. Please see the solution process once. Let's go for a common data question. Question number 15 and 16. Get 2013 question. It is. Get 2013 question. At a station storm 1 of 5-hour duration with intensity 2 centimeter per hour resulted in a runoff 4 centimeter. And storm 2 of 8-hour duration resulted in a runoff of 8.4 centimeter. Assume phi index is same for both the storms. Then first question, phi index in centimeter per hour is Second question. The intensity of storm 2 is. Please solve this question. Let's solve this question. IE is 2 centimeter per hour. Effective time is 5 hours. Runoff is 4 centimeter. Sixteen. 5 is PE minus R2 by TE. PE minus 8.4 by 8. So PE will be 8 into 1.2 plus 8.4, it's 18 centimeter. So as they're asking for intensity, it's 18 by 8, 2.25 centimeter per hour. So as they're asking for intensity, it's 18 by 8, 2.25 centimeter per hour. I'm sorry to hear, Vishwanath. Actually, throughout it's almost a 4-hour classes are going on. Till now, everything is okay. I'll again restream it. Just hold on. Just let me finish this this infiltration and runoff. I think it is correct now. I think it is correct now. Question number 17. Get 2004 question. The rainfall during 3 successive well, let me finish this infiltration runoff. Just last question it is. When after that I will restream it and then I will go for the hydrograph problem. Let me finish this infiltration runoff. Just last 2-hour periods are 0.5 to 0.8 and 1.6 centimeter. The rainfall during 3 successive 2-hour periods are 0.5, 2.8 and 1.6 centimeter. The surface runoff resulting from this storm is 3.2 centimeter. The phi index value will be. So actually here P 4.9 centimeter, R is 3.2 centimeter. So W is precipitation 4.9 minus 3.2, 0.283 centimeter per hour. So that means what? All are 2-hour periods. So first storm, it's 0.5 by 2, it's 0.225. Below W, 2.8 by 2, it's 1.4. Above W, 1.6 by 2, 0.8. Above W. So anything below W line will be always below phi line. So we'll remove that. Eventually your P will be 2.8 plus 1.6 is 4.4. Phi is 4.4 minus 3.2 by 4. So 1.2 by 4 it's 0.3 centimeter per hour. That's the end of infiltration and runoff itself. That's the end of infiltration and runoff also. 1.2 by 4 is 0.3 centimeter per hour. That's the end of infiltration and runoff itself. That's the end of infiltration. Now we need to go for the chapter hydrograph. Guaranteed question segment of hydrology. Now you're going for the problems on hydrograph. Now you're going for the problems on hydrograph. Hope it is okay now, the voice part. If you get repeating, it is because I have just. No, going for question number 18. A direct runoff hydrograph due to an this figure is provided. This figure is provided. And that is the question. First question, very important type. This also get 2000 question. A direct runoff hydrograph due to an isolated storm with an effective rainfall of 2 cm was trapezoidal in shape. It corresponds to a catchment area of. Please solve this question. So actually area of catchment is volume of runoff by the depth of so area of catchment is volume of runoff by the depth of runoff. Volume of runoff is nothing but the area under the curve, trapezoid, That is equals to, what is area under the trapezoid? Half into 70 plus 4. The summation of the parallel line into the 2 centimeter 1000 square. Why? Because it's in meter cube, so directly finding out in kilometer square. 599.4 kilometer square will be your answer. 599.4 kilometer square will be your answer. Now going for question number 19. A DRH due to a storm over a basin has a time base of 90 hours with straight line portions of hydrograph with flow rates of 0, 10, 70, 90, 40 and 0 meter cube per second at elapsed duration of 0, 10, 20, 30, 50 and 90 hour. The area is 300 kilometers square. What is the rainfall excess? And a figure like this is given. Let me draw. This figure is given. So please solve this question. Very, very important type of question. Please solve this question. Very, very important type. Let's solve this question. Now they're asking the rainfall excess, right? That means the runoff depth. Which is equals to volume of runoff by area of catchment. Now area of catchment is provided. What will be the volume of runoff? It's area under the curve by area of catchment. Now this area under the curve is not of a regular area, so we have to truncate it. This is A1, this is A2, this is A3, this is A4, this is A5. So A1 is what? It's a triangle. 0, 10, peak is 10. So it will be half into 10 into 10 to 3600. Like this, what will be A2? It's a trapezoid, right? It's 10, it's 20, it's 10, it's 70. So A2 will be half into the summation of the parallel side. It's what? 70. This one is 10. 10 plus 70 plus the this one is the perpendicular distance between the parallel side, that is 10 itself, in 3600. On similar fashion, A3 will be half into 70 plus 90 to 10. A4 will be half into 90 plus 40 to 20. Similarly, A5, it's a triangle, half into 40 into 40 in 3600. Correct? So the total area under the curve which is the volume of rainfall, volume of runoff. Here it is nothing but A1 plus A2 plus A3 plus A4 plus A5. Finally, if you calculate, it will be the excess rainfall will be 4.02 centimeter will be your final answer. 4.02 centimeter will be your final answer. Clear? Have a look. Now going for question number 20. The successive, very important type of questions. By this question you can get lot many things directly. The successive 3 hourly ordinates of a 6-hour unit hydrograph for a particular basin are 0, 15, 36, 30, 17.5, 8.53 cubic. The flood peak observed due to a 3-hour storm sorry it's 6 hour is 150 cubic. Assuming a constant base flow of 6 cubic, assuming a constant assuming a constant base flow of 6 cubic and an average storm loss of 6 mm per hour. Determine the depth of storm rainfall the stream flow at 15th hour. Let's see the solution process for this question. Peak flood resulting for 6-hour storm is 150 meter cube per second. Base flow 6 meter cube per second. So peak flood of 6-hour DRH will be obviously you need to negate the base flow 144 meter cube per second. The runoff loss is given as something. So peak ordinate, it's given peak ordinate of 6-hour unit hydrograph 36 meter cube per second. So peak ordinate of 6-hour DRH is equals to peak ordinate of 6-hour unit hydrograph into R runoff excess. So first is 144 is equal to 36 into R. So R is equals to 4 centimeter. Phi is given as 6 mm per hour, and phi is PE minus R by TE. So eventually PE will be 76 mm. Our effective precipitation is 7.6 centimeter. Here, effective precipitation is 7.6 centimeter. Okay. Now the stream flow at the 15th hour, right? So time interval and 6-hour unit hydrograph ordinates 0, 0, 3, 6, 9, 12, 15, 3, 15, 6, 36, 9, 30, 12, 17.5, 15, 8.5. And obviously, as they're asking the stream flow, you need to add the base flow. Okay. Let's go for question number 21, which is GATE 2004 question. Question number 21, GATE 2004. I'm just solving here all the important type of questions. The average rainfall for a 3-hour duration Storm is 2.7 centimeter and the loss rate is 0.3 centimeter per hour. Flood hydrograph has a base flow of 20 meter cube per second and produces a peak flow of 210 meter cube per second. The peak of a 3-hour unit hydrograph is the peak of a 3-hour unit hydrograph is question number 21. Let's solve. PE is equals to 2.7 centimeter, TE is 3 hour, phi is 0.3 centimeter per hour. Phi is P minus R by T. 0.3 is 2.7 minus R by 3. Now peak of 3-hour flood hydrograph is 210 meter cube per second. Base flow 20 meter cube per second. Peak of 3-hour DRH is equals to peak of 3-hour flood hydrograph minus base flow, that is 210 minus 20, it's 190 meter cube per second. So peak of 3-hour unit hydrograph will be equals to direct runoff hydrograph peak by runoff depth. It's 190 by 1.8, which is 105.55 meter cube per second. Hope you are now on track to solve this type of questions. So 21. Now we are going for question 22 and 23. Common data question. That's why I'm telling like this. 22 and 23. Get 2012 question. Get 2012 question it is. Question number 22 and 23. After solving this, we'll solve next question. An average rainfall of 16 centimeter occurs over a catchment during a period of 12 hours with a uniform intensity. The 6-hour unit hydrograph rises linearly from 0 to 30 in 6 hours. And falls linearly from 30 to 0 in the next 12 hours. Phi index is 0.5 centimeter per hour. Phi index is 0.5 centimeter per hour. Base flow in the river is known as five cumex. Question number 22 will be peak discharge of the direct runoff hydrograph will be peak discharge of DRH will be question number 23 area of catchment in hectare. Solve this question, very important type. let's solve. So we are in the verge of completion of this part. As per the problem statement, it rises linearly up to 30 in the first 6 hours, then it falls to 0 in the next 12 hours. So it is so obviously the total will be 18. Okay, so to find out at the 12 hours, so it is 6 if it is 12. So what will be the peak as per the equilateral triangle concept? So yeah, 15 only. Duration of rainfall is 12 hours, but they have given provided the 6-hour unit hydrograph, right? So we have to find out the 12-hour unit hydrograph first. 0, 6, 12, 18. Q for 6-hour unit hydrograph is 0, 30, 15, 0. Again, 6-hour unit hydrograph with 6-hour lag, because 2 6 hours along with the 6-hour lag will provide you 12-hour unit hydrograph. 0, 30, 15, 0 in 24, right? It's 0. 12-hour delayed run of hydrograph. Addition of these two: 0, 30, 45, 15, 0. So 12-hour unit hydrograph divided by 2 only, 0, 15, 22.5, 7.5, 0. Clear? So peak discharge of 12-hour unit hydrograph is 22.5 meter cube per second. Peak discharge 12-hour direct run of hydrograph is 22.5 into 10, because R is 10 centimeter, we have 225 meter cube per second. Question number 23 asking area half into 30 into 18 into 3600 by 1 by 100 into 10 to the power 4. It is 9720 hectare. That's 9720 hectare will be the area itself. Okay. Now, last question, question number 24. A 6-hour unit hydrograph A 6-hour unit hydrograph of a catchment is triangular in shape with a base of 64 with a base of 64 hours. The peak ordinate is 30 meter cube per second. Calculate the equilibrium discharge of an S curve So volume of runoff actually it's triangular in shape with a base of 64 hours. P coordinate is 30 meter cube per second. It's half into 64 into 30 into 3600, 3.456 into 10 to the power 6 meter cube. Runoff depth 1 centimeter, it's 0.01 meter. So area 3.456 into 10 to the power 6 by 0.01, which is 345.6 kilometers square. Now we know that equilibrium discharge two point 778 A by D. Equilibrium is that's the end. So guys, what we have done today, solved all the type of problems from different chapters of hydrology, what we have discussed in the previous classes. If you understand all the questions, we have discussed well hydraulics also. That is a complete course of hydrology you are having now. Now, hope all the segments, all these things are pretty clear to you. If you're having any kind of doubts, please let me know. So that is the end of today's discussion process. So let's crack GATE and ESE. This course will help you to secure 4 to 5 marks. That's my guarantee. Hold all the 3 classes that will give you. Subscribe this channel, and also hit the bell icon for the notifications, and don't forget to apply the code SEN10 SEN10. Subscribe the channel, just get civil, and join our Telegram group for latest updates on our upcoming videos. So for GATE 2021, I have given all those whatever is required for you. In hydrology, I have told that I will take 15 hours. Actually, I have taken a bit more than that. I have taken 15 hours, around 45 minutes. So hope you have liked the class, please. And also, I have written in one slide my link for the app classes. They will get lot many free classes on environmental engineering. In this channel also, you can get the free classes of environmental engineering, YouTube classes of environmental engineering in details. unacademy.com/@soumyajitsen.iitb-7305 is my core process. So goodbye as of now. If you are having any kind of problems, please let me know, and all the best for your any kind of future endeavor. Goodbye.